Okay, these notes are titled Solving Two Variable and Systems of Inequalities. The essential question is, how is determining where to shade similar or different when graphing a single inequality versus a system of inequalities? How is determining where to shade similar or different when graphing a single inequality versus a system of inequalities? Okay, so the first example, we're going to learn how graphing inequalities works. So example 1, we're going to graph y is greater than or equal to negative 2x plus 1. Okay, remember that symbol is less than, this symbol is greater than. If it looks like an L and you can put ESS in it and it spells less, then it's less than. Now this is really nice because it's nearly in the form y equals mx plus b. The only difference is instead of an equal sign, we have an inequality symbol. Remember, m stands for slope. And we use the phrase rise over run to help us graph the slope. And b is the y-intercept. So even though this is an inequality, we can still graph it, pretending that it was an equation using the same properties. We have our y-intercept and our slope. Okay, so to graph it, we need to draw a graph. So go ahead and set up some axes. Coordinate plane, we have our y-axis and an x-axis. Label them y with arrows and x with arrows. And it's also good to go through and the number 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. Negative 5. 1, 2, 3, 4. Positive 5. Okay, first of all, you graph your y-intercept. So it's going to cross the y-axis at y equals 1. So on the y-axis at 1, put a nice solid point there. Secondly, we use the slope. So the slope in this case is negative 2 over 1. So we're going to rise 2, run 1. Now when we rise negative 2, that means we go down. So from the intercept point that you've already plotted, you go down 2, run 1. Guess you can't see that blue, huh? Let's try a new color. How about that? Down 2, run 1. Down 2, run 1. You keep going until it's off your graph. Now for the points up here, we can see it's linear because it's x to the first power. We can reverse it. We can go up 2, left 1. Up 2, left 1. Now before you draw a line, there's something important we need to know about inequalities. Okay, when it's one of these, less than or greater than, we have a dashed line. When it's less than or equal to or greater than or equal to, we have a solid line. So in this case, we have an underline. If we have an extra line, we have the extra fill, and we fill it in with a solid line. So you can grab a ruler or something that has a straight edge and connect them with a solid line. So you have to be careful. Sometimes we're going to have a dashed line. In this case, it's a solid line. Now there's a new step. We have to determine where to shade. Okay, we determine where to shade by picking a test point. Pick a test point. Okay, when we pick a test point, quite often it's easy. A really nice point to use is 0, 0, but 0, 0 in this case is too close to the line, so I don't want to pick it. Another point that would be easy to use is when x is 0. So x is 0 when you're on the y-axis. So I'm going to choose a point that's on the y-axis that's not close to my line. So how about the point right here? 0, 5. When I pick my point, I'm going to plug it in to my inequality and determine if it's true or false. Remember, x is first, y is second. So y, we're going to put in 5, is greater than or equal to negative 2x. When we plug in the x, we put parentheses. The x was 0 plus 1. And now what's really nice is if you pick your test point that's on the y-axis, you're using an x that's 0. Anything times 0 cancels out to 0. So now I have 5 is greater than or equal to 1. Is this a true or a false statement? Is 5 greater than or equal to 1? That is true. So the side that this point is on is true. So what we're going to do is we're going to shade everything on that side. So let me grab a crayon here and choose to shade it with a crayon. That's probably better. So everything on this side of the line is true. We could pick any point in this green shaded area and it would always work out to be true. If I pick a point over here on the non-shaded side, you get a false statement. So you don't shade the false statement side, you shade the true statement sides. Okay? So that's a linear. Let's look at a different kind. Same properties though. Example 2. We're going to graph y minus 4 is greater than or equal to 2 times the absolute value, x minus 1. Close the absolute value. Now we want to get this with y by itself. So in this case, we need to do some inverse operations. We're going to add 4 to both sides. Now that comes after the absolute value. Don't add it inside the absolute value. Now careful with absolute or with inequalities. If you multiply or divide by a negative on both sides, you have to flip the sign. So keep that in mind. In this case, we were adding 4, so adding, we don't have to worry about it. But if you multiply or divide by a negative, you have to flip the sign. So we can keep our sign the same. Y is greater than or equal to 2. Absolute value x minus 1, absolute value plus 4 goes after the absolute value. Now, if you recall what we've been doing for an entire term, you should know what this minus 4 and the positive 4 does to the graph. The minus 4 is a horizontal shift. The positive 4 is a vertical shift. So we go opposite, same. Now when we're doing our graph this time, it's an absolute value. Absolute value has a vertex. So we want to get some points. And if you understand how to get the vertex, then you'll know where the center of the graph is. So the center of our graph where the vertex is opposite, same. So we'll go 1, 4. We want that in the middle. 1, 4. And you want to pick a couple points smaller, 0, negative 1 are smaller, and a couple points bigger, 2 and 3. But 1, 4 is very important to have that in the middle because that's your vertex. Okay, so let's plug in 0. Y is going to be greater than or equal to 2 times the absolute value of 0 minus 1, close the absolute value plus 4. When we're simplifying, remember, please excuse my dear Aunt Sally, parentheses actually stands for grouping. So this absolute value is a grouping. So we get 2 absolute value, negative 1 plus 4. The absolute value of negative 1 is positive 1. So it becomes 2 times positive 1 plus 4. And 2 times positive 1 plus 4 is 2 plus 4, which is 6. Okay, now really we only have to plug in the negative 1, and then we can use symmetries for these other two. So now I'm going to plug in, this is my work. I kind of ran out of room, so I'm going to have to do it down here. I'm going to plug in negative 1. 2 absolute value, now instead of the x, or instead of the 0, we now plug in negative 1. minus 1. Make sure those absolute value bars are extra long and tall so they don't look like 1s themselves. Now we use the grouping. Negative 1 minus 1 is negative 2. So 2 absolute value negative 2 plus 4. And remember, you have to do the absolute value first. Absolute value negative 2 means the distance from 0. Negative 2 is 2 units from 0, so it's always positive. 2 times 2 plus 4. Multiply first. 2 times 2 is 4, plus 4 we get 8. And using symmetry, we now know these ones. Oops, wrong way. Okay, using symmetry, because we have the vertex here, you can see one step away, the y's will be 6's, 2 steps away, the y's will be 8's. So now we're ready to graph. And actually, if I look at all of my y values, all of them are positive, so I'm just going to do a t graph. Making sure I have enough room to go up to positive 8. Labeling with arrows, x and y. Okay, 1, 2, 3, 4, 5. Make sure you number 6, 7, 8, 9, 10. That's plenty of room. On my y's, I need to go from negative 1 to 3. So here's negative 1, 1, 2, positive 3. And you just plot the points, but don't connect them yet because we have to determine if it is solid or dashed. So negative 1, 8, 0, 6, 1, 4. Now here you should see it turn around. To 6 it goes back up because the vertex should be the minimum point in this case. 3, 8. Now don't connect them yet. Let's look at the sign and determine if it is solid or dashed. We have the equal to. So if you go back up to our chart, if it's equal to, we have an extra line, we have extra fill. So we have to fill it all the way in. So when we make our V for the absolute value, which is a V graph, it will be solid. Now there are two different places we can shade. We can either shade on the outside of the V, or we can shade on the inside of the V. We have to determine which one. We determine which one by picking a test point. We plug it in and determine if our statement is true or false. Okay, now the easiest point to use is 0, 0, but only use that as long as it's far away from the graph. See, the last one, 0, 0, was too close, so I didn't want to use it. So my second alternative was to pick a number on the y-axis, because then I'm working with at least 1 0. And working with zeros is really nice. So I'm going to use 0, 0 this time, because it's really far away. So inside this inequality right here, I'm going to use the test point 0, 0. I'm going to plug it in. So instead of y, I'm going to plug 0 is greater than or equal to 2 times the absolute value. Instead of x, I plug in 0, 0 minus 1, absolute value, close it up, plus 4. Using your, please excuse my dear Aunt Sally, let's do grouping first. 0 minus 1 is negative 1. Make sure your absolute value is nice and tall so they don't look like 1s, plus 4. Now let's simplify the absolute value. Absolute value of negative 1 is, what's the distance negative 1 is from 0, which is positive 1. 2 times 1, it's multiplication. Okay, then we do multiplication before we add. 2 times 1 is 2, plus 4 is 6. So 0 is greater than or equal to 6. Remember, the point we've picked is way down here, 0, 0. That's our test point. Is this true or false? Is 0 greater than or equal to 6? Well, I'm pretty sure that is false. So that means this point is false. So we do not shade. We only want to shade the true area. So everything where that point is false, which means the true area is inside of the V. The true area is inside of the V. Last time we got a true point. So we're able to shade, because this point we got up here was true. We shade the true area. But the point we picked this time happened to be false. So any point we pick out here will always give us a false statement. So none of this is shaded. We only shade the true area. Okay, let's try another one. Example 3. Y plus 3 is greater than x squared minus 2x. Okay, again, y is not by itself. Let's make sure y is by itself. So first I'm going to subtract 3. And when we subtract, it's okay. We don't have to worry about flipping the sign. It's when you multiply and divide by negatives that you have to flip the sign. So our sign's going to stay the same. And I'm going to put this in standard form. X squared minus 2x minus 3. None of these are like terms, so we're not going to combine any of them. Notice this is not an absolute value. It's also not x to the first power, which is linear. This is x squared, so this is a quadratic. So we should get a U parabola shape. Okay, so when we are graphing parabolas, we want to graph around the vertex again. So we'll need a table of values, x and y. We'll want to put the vertex in the middle. Now remember, this is how you find the vertex. First you identify the axis of symmetry. When it's in standard form, axis of symmetry is the beginning and end of the quadratic formula. X equals negative b all over 2a. Okay, b is negative 2. So negative 2 is positive 2 over 2 times a. A is 1. So 2 divided by 2 means our axis of symmetry is x equals 1. That is the x-coordinate of your vertex. To find the vertex, you plug that in. Okay, to plug in the vertex, wherever there's an x, we put a 1. We have y is greater than 1 squared minus 2. Now there's another x, so we'll put parenthesis 1 minus 3. So we have 1 squared minus 2 minus 3. Do exponents first. 1 squared is just 1, minus 2 minus 3. And we subtract left to right. 1 minus 2 is negative 1, minus 3 is negative 4. So our vertex is the point we plugged in 1, we got negative 4. That's our vertex. So on our table over here, we'll want 1, comma, negative 4. That's our vertex. Okay, now again we need to pick a couple points smaller, 0 and negative 1. A couple points bigger, 2 and 3. Okay, and we can plug in each of them into our quadratic. We really only need to plug in 2 because we can use symmetry around the vertex to get the other 2. So let's first plug in negative 1. For our work, y is greater than, we plug in negative 1. Now parentheses are very important. Make sure you do parentheses negative 1 squared. Minus 2 times negative 1 minus 3. Again, you do parentheses first. Negative 1 squared is positive 1. With the parentheses and exponents right there, actually. Okay, now we have multiplication. Negative 2 times negative 1 is positive 2 minus 3. Now you add and subtract left to right. 1 plus 2 is 3, minus 3 is 0. Now let's plug in the 0, which working with zeros is really nice. So we'll do 0 squared. Use parentheses, even though it's a 0, it's a good habit to use parentheses. Wherever there's an x, I plugged in a 0. Wherever there's an x, I plugged in a 0. 0 squared, we'll do exponents first. 0 squared is 0. Then we multiply. Negative 2 times 0 is 0. You can add or subtract that, doesn't really matter. So 0 minus 3 is negative 3. Now using symmetry, we have negative 3, 2 comma negative 3, and 3 comma 0. Okay, now we're going to graph it, determine if it's solid or dotted, and then determine where to shade. Now if I look at all these, I have some negative y's, no positive y's though, so I'm going to do a t graph. That should work nicely. Okay, and t-graph, it's always nice to look at what you're graphing before you start setting it up, so you don't have to do extra work. Okay, negative 1, 1, 2, 3 on my x-axis, which of course I label and put arrows on. And my y looks like I need to go down to negative 4. 1, 2, 3, negative 4. Okay, just plot the points. Negative 1, comma 0. So we go left, negative 1, up and down 0. 0, comma negative 3, we just go down negative 3. 1, comma negative 4, down to negative 4. 2, comma negative 3, oh, it comes back up because that was our vertex. 3, comma 0. Now, before we connect these, we have to determine, is it closed or open? And we determine that by looking at the sign. Look at the sign all the way through this. It's always just greater than, no line. So if you look at our notes before, no line, no fills, so it's going to be dotted. So this is a different type of parabola than we've seen before. Dotted, so put a little dashed or dotted parabola. Still with arrows though. Now we have to determine where to shade. We determine where to shade by picking a test point. Like I've said before, 0, 0 is a great one to use, and it's not very close to our parabola, so I'm going to pick 0, 0. It's so easy to use zeros. Okay, so here's our original. Wherever I put have an x or a y, I put in a 0. So instead of y, I'll put 0 is greater than x squared, so we put 0 squared, minus 2 times 0 minus 3. And we just simplify and determine, is this a true statement or a false statement? Exponents first. 0 squared is 0. Then we multiply and we get 0 minus 3. So 0 minus 0 is 0. Minus 3 is negative 3. So true or false? Now you have to know what these symbols are. This is a greater than symbol. 0 is greater than negative 3. True or false? 0 is greater than negatives. I think that is true. Now where was that point on our graph? It was right here. That's a true point. So anything true is what we shade. So anything inside of here would always give us a true value. So shade inside. Okay, now lastly we're going to graph a system. Example 4. Graph a system of inequalities. Okay, a system means we're going to have more than one. Y is greater than or equal to x squared minus 4. And y is less than negative x squared minus x plus 2. So we have two inequalities. Okay, so maybe I'll call this y1, and maybe I'll call that y2. I'll just add in the 1 and 2 so I know which one we're talking about. So for the first one, we need to get some points. We need to know the vertex, and we need to know some points so we can graph it. So for y1, let's find the vertex. So axis of symmetry, x equals negative b all over 2a. b is x to the first power. There is no x to the first power, so that means 0. There is 0x to the first powers. All over 2 times a was the coefficient of x squared, which is 1. 0 divided by 2 is 0. So now we're going to plug it in, x equaling 0, and then we'll have our vertex. Okay, so y1 is greater than equal to x squared, well, it would be 0 squared minus 4. I forgot today was short day. Oopsies. Y1 is greater than or equal to negative 4. I'll have to pause this video and finish it in just a couple minutes. Okay, so back to this problem. Graphing a system of inequalities, we were finding the vertex because we found the axis of symmetry was x equals 0. We plugged in 0. We got negative 4. So this vertex is 0, 4. Okay, so when we do our xy table, to find points for y1, I'll put y1. So remember, this is for the top function. I want 0, 4 to be in the middle, because I want my vertex to be in the middle. And then I pick a couple x's smaller, negative 1, negative 2, and a couple x's bigger. How about positive 1? That's better. Positive 2. Now I plug them in. Since I'm squaring, it doesn't really matter if I use the top ones or the bottom ones. It's up to you. I'm just going to start on the top. I plug in negative 2 squared. Make sure you use parentheses, minus 4. So negative 2 squared is positive 4 minus 4, which is 0. So I put 0 there. Now I do it again for negative 1. I plug in negative 1 squared. Parentheses are very important, so make sure you have those parentheses. Negative 1 squared is positive 1 minus 4 is... Oh, this is negative 4. I'm like, this isn't making sense. Why not? This should be negative 4. Because here we get negative 3. That's better. So make sure your vertex is 0, negative 4. Now using symmetry, we can plug in the other ones without doing any work. Negative 3, so the first one down here is negative 3. Second one up was 0, so the second one down is 0. Okay, so let's start graphing that. I'm going to do my graph over here, though, so I'm going to zoom out a little bit. Let's see, the y-axis, arrows, and an x-axis. Like that was wet. With arrows, y and x. So let's plot the points for y1. Negative 2, 0 is right here. Negative 2. Negative 1, down 1, 2, 3, negative 3. 0, negative 4. 1, negative 3. You can see it coming back up. 2, 0. That's 2. Now, look at the sign. Greater than or equal. So that means this should be filled in, and it is a parabola. So we're going to do a solid line. Now for this one, let's pick a test point and determine where to shade. Test point. Guess what? Our friend 0, 0 is a good one to use because 0, 0, not close to the line. So I'm going to plug it into the top. Wherever there's a y and an x, I plug in a 0. 0 is greater than or equal to 0 squared minus 4. 0 squared is 0. So 0 minus 4 is minus 4. Is it true or false? 0 is greater than or equal to negative 4. That is true. So this point, 0, 0, is true. Remember, we shade the true area. So this time I'm going to do it lightly because there's some more shading coming up. So I'm going to shade lightly. Inside there was the true area. Now that's only the first inequality. Well, there's a second inequality. Okay, so we're going to do an x, y table for the second inequality. Again, we're going to need to find the axis of symmetry so that we can identify the vertex. I'm kind of running out of room. I'm going to come up here. Axis of symmetry. X equals negative b all over 2a. Negative b. We have b is negative 1, so it'll be negative 1 all over 2 times a. A is also negative 1. So a negative 1 is a positive 1. And 2 times -1 is -2. So our axis of symmetry, x equals -1/2. Okay, now we plug it in to find the vertex. y2 is less than -1/2 squared minus 1/2 plus 2. Ooh, because this is fractions and we're squaring it, I'm going to cheat a little bit and just type it in with, and to save on time on these notes as well. I plug in the parentheses exactly how I wrote it, 1 divided by 2 plus 2. I get 1.25. Okay, the decimal's nice for graphing purposes. So x and y2, the x was -1/2 and 1.25 was the y for the vertex. Now we want a couple smaller and larger than -1/2. I'm going to go with integers here. I'm going to do -1 and -2. Then I'm going to use 0 and 1. And they're each a half step away from -1/2, so that's legal. So I'm going to choose this time to plug in the positives down here. -0 squared minus 0 plus 2 will just be 2 because of those lovely zeros. -1 squared minus 1 plus 2, we square first. We get -1 minus 1 plus 2. So add and subtract left to right. -1 minus 1 is -2, plus 2 is 0. Okay, because this is a half step away from -1/2, and -1 is also a half step away, we can use symmetry, so that would be 2 and 0. So time to plot these points. -2, 0. Oh, interesting. It's a point right there. -1, 2. -1, we go up 2. -1/2, 1.25, right about there. 0, 2. We start coming back down with the parabola. 1, 0. 1, 0 is right here, and it looks like I might actually want to do one more because they haven't intersected yet. So I'm going to plug in 2. -2 squared minus 2 plus 2. So we get -4 minus 2 plus 2. And the minus 2 and the positive 2 cancel each other out. And I get a -4. So positive 2, 1, 2, 3, -4. There we go. Now, don't forget, open or closed. Over here we have just less than, so it should be open, which in this case looks like a dotted parabola. And we have to again pick a test point and determine a test point to see if we should shade inside the parabola or outside the parabola. I'm going to use my friend 0, 0 again. Plug it in. 0 is less than -0 squared minus 0 plus 2. Zeros are so nice. 0 is less than 2, true or false? That is true. So notice 0, 0 is inside the blue parabola. 0, 0 is inside the blue parabola. So and it was true. So everything inside the blue parabola is also true. So I'm going to pick a different color, and I'm going to shade where this one was true. Now, we have 2 shadings this time. So the actual solution to this inequality is where we have both red and brown shading. And can you see that that happens right here? Both brown and red. So where I'm shading in blue is the solution. And we have solid parabola on the bottom and a dotted or dashed parabola on the top. That's the solution.